Hello everybody, this is Mr. Bowman. Today we're going to be looking at the ALEKS topic, proof involving points on the perpendicular bisector of a line segment. So, here's the given information to prove the following theorem. If a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of a segment. Okay, good to know. So, we're going to let P be any point on line L, so not a specific one. It's not going to be 1 inch away or 1 unit or anything like that, just at any general point. But it has to be not X, because that would be really unhelpful, because it's bisector, we know it's there. All right. So what do we know? We know, given that Px is the perpendicular bisector of line segment WY. Prove that WP equals YP. So looking at these ones to the other points. Okay. So statement. Reason. All right. Statement. Let's start with our given. Okay. Px is the perpendicular bisector of WY. Okay, given. Alrighty, so what do I know from that statement? It's a great statement, but I need to draw actual conclusions. So I know two main things from that. And one of the big ones is I know that this is our perpendicular. Those are both 90 degrees, or more specifically, they're both congruent. So I think if we're being technical, we should do this in 2 steps, so that's what we're going to do. So angle PXW and angle PXY are right angles by the definition of got ahead of myself. Definition of perpendicular. And because they're both right angles, they are congruent to each other. Okay. So after a while, I've seen a lot of people jump straight from bisectors, so they have to be equal, because every intersection at a bisector are 90 degrees, but be technical here. We should list that out. All right, so I know that. I also know, since they're bisectors, that means these two things have to be equal as well. So I can go straight to that. XY has to be congruent to XW by the definition of bisector. All right, and what else do I know? I know this is a shared side, so I can say that XP is congruent to XP. That's the reflexive property, something that's congruent or equal to itself. All right. And that's actually enough to prove these triangles are congruent, because I have 2 sides and an angle in between them. So that would be the SAS property. So triangle WXP is congruent to triangle YXP. All right, and I want to prove that WP is equal. So the length here have to be equal. So I have to actually do this in 2 steps. So I can say that line segment is congruent to the other line segment. Okay, and that's through CPCTC. Now I can say that the lengths are equal, So the lengths are the same through the definition of congruent segments. Okay, so a couple of steps that don't seem entirely necessary in there, but they are important. So we'll just go ahead and list them all out, and that's how that one will work.